The change of base law with logarithms is basically what we use so that we can find any logarithm using our calculator. Now the calculator has two buttons to find logs. It has the log button, which automatically finds logs with a base of 10. We also have another button called ln, and it automatically finds logs with a base of e. Now, we'll deal with e later, so it's important to know that we could actually use e in our formula here, but for today we're going to use 10. The important thing is that the numbers in our base need to be the same. So we either use 10 and use the log button, or we'll use e and we'll use the ln button. Now, what does this change of base law look like? Well, it says that if you take any log where we've got a base of a and the log is of x, then you can break it up into a fraction where you've got the log of x to a certain base over the log of a to that same base. So we're taking these two numbers here, putting one in the numerator, one in the denominator, and giving them both a log with the same base. Now, let's have a look at a proof to see why this works. If we write a basic log expression like this, we can rewrite it and say a is the base. It really means a to the power of y equals x, doesn't it? Now, if we can agree that these two things are equal, they'll still be equal if we do the same function to them, or the same operation. So just as if we had two things that were equal, you'd agree that if we squared them both, they'd still be equal, because squaring is just an operation you can do. Or if we said we had an expression of two things that were equal, then if we took the square root of both of them, the equation would still hold true, wouldn't it? Now, squaring and taking the square root, they're operations that we already know how to do, which is why I've used them as examples. Here, we want to actually take the logarithm of both sides, which is something we haven't really looked at yet. But if we take the logarithm of this side and the logarithm of this side, the equation should still be true as long as the logarithms that we took both had the same base. So let's go ahead and do that, and let's use logarithms with a base 10, so that then we can use our log button on the calculator. So log of base 10 of this side must equal log of base 10 of this side. Okay, now we can't do much with this, so we'll just write it out again. But this one, we've just learnt the power law, which says that this y can come down the front here. And we can have y multiplied by the log of base 10 of a. Alright, now if we want to get y by itself in this equation, we've got y multiplied by all of this. So we just need to divide both sides by log of base 10 of a. So y will equal, well, if we divide it here it will disappear, but over here we need to divide by the log of a with base 10. And that's pretty much given us our rule. So we started with y equaling this, and we ended up with y equaling that. So these two things must be equal to each other. Now, how do we use it? Well, we use it so that we can find the logs of anything in our calculator. So, for example, just say we're solving a problem and we end up finding that our answer is something like this. And we think, well, what is that? Well, we know ballpark what it is. This means 2 to the power of something is 5. I know 2 squared is 4, and I know 2 to the power of 3 is 8, so it's going to be a number between 2 and 3, but I can't figure it out off the top of my head. But using my calculator, I can say that's the same as the log of base 10 of 5 over the log of base 10 of 2. Now these are both numbers I can put in my calculator. The way to do it is just literally type in the log button and then hit 5. You'll need to close the brackets around the 5. Over, hit the log button again and put brackets around a 2. And then hit the equals button and you'll have the answer there, which comes out as log of 5 over log of 2, and we get 2.32192. It's a big long number, let's just round it off to 2 decimal places. And now we have an answer to our question.